Before the advent of satellites, professionals relied on ground observations, weather balloons, seismographs, and ship reports to monitor and predict natural disasters.
Do get rain and storms or severe weather like we saw this morning, we use several tools to forecast what's coming, including weather balloons. Now, you may have heard about these from time to time, but have you ever seen how one works? Well, you will today. WFAA meteorologist Mariel Ruiz shows us how these balloons keep us safe.
These methods, though valuable, were limited by distance, time, and accessibility, making it difficult to see the bigger picture of Earth's ever-changing patterns.
So that's why it's so unpredictable, and we can't really blame the DILG or local officials for
It's
Pag-asa.
really hard to
You're right,
predict.
Pawi.
It's really hard to predict according to the meteorologist faculty member of UP.
And that's what our own weatherman tells us also, that it's really unpredictable.
Then came satellites, revolutionizing disaster tracking by providing real-time data and images from space, allowing scientists to observe storms, volcanic eruptions, and earthquakes with unprecedented accuracy. From a single bird's eye view, let it be a lens, and it will make sense.
Humans started forming society way back about 2 million years ago. And from then on, it has been their innate ability to stay curious. Soon, this ever-growing curiosity sparked innovation. From simple fire to burning stove, from being nomadic to building houses, and from hunting food to order it with a single tap on phones. This never-ending curiosity not only shaped modern tools, technology, and culture, but also reached beyond the skies of the earth.
Bansa ang ubod ng lakas na bagyong Yolanda sa dagat Pasipiko. 1,221
schools and government offices have been closed in the Manila region and dozens of other provinces in anticipation of heavy rainfall.
Hirap ng buhay yan. Hirap ng buhay at kalooban. Lalong-lalo na sa alang mga supisyente.
Nawalan ng bahay, nawalan ng gamit at hanap buhay. Pero hindi pa rin nawawalan ng pag-asa si Salve na makita ang nawawalang mister na
The
si
Philippines, they suffer typhoons. You suffer typhoons on a routine basis. How does this particular one, how does
malaki sa kapitera ng lalawigan ay hindi pa rin nakakakita ng tulong. Kwento nila, napakahirap ng kanilang pinagdaanan ang sila'y sinilanta ng pinakamalakas na bagyo na kanilang nakita sa katanduan.
Throughout history, the Philippines has been prone to numerous natural disasters, with typhoons being the most destructive and frequent. Located within the Pacific Ring of Fire and the Typhoon Belt, the country constantly faces the threat of volcanic eruptions, earthquakes, and especially powerful tropical storms. Every year, an average of 20 typhoons enter the Philippine area of responsibility, with several making landfall and leaving behind devastating impacts. Destroyed homes, lost livelihoods, and countless lives affected.
Pagbalik ko dito, lahat ng bahay dito, inabutan na ng tubig. Lahat. Wala nang natira dito. Ang tubig napakalaki na. Parang dagat ng tubig. Lahat ng bahay naanod na.
These recurring disasters not only endanger communities but also hinder national progress and economic stability. Adding to this, the environment continues to deteriorate due to both human activities and natural processes. Deforestation, pollution, and improper waste disposal worsen flooding and landslides during typhoons, amplifying the damage. The country's rich biodiversity and natural resources, once abundant, are now under threat. If these environmental issues and the effects of natural disasters continue to be neglected, the consequences could become far more catastrophic. It is therefore essential to take proactive measures through disaster preparedness, environmental protection, and sustainable practices to safeguard both the nation and the generations to come.
Satellites became humanity's eyes above the sky. These are objects that orbit a celestial body. They can be natural, like moons, or artificial, like the ISS, the largest artificial satellite yet made. Satellites serve many functions: communication, broadcasting, navigation, weather forecasting, research, and Earth observation. Humans have created thousands of them for these very reasons. Thanks to satellites, people can live with more ease by using GPS on roads, calling distant loved ones on the phone, and watching live weather forecasts before going to work or school. Today, more countries have begun to own satellites, such as Germany, Italy, India, Japan, and even the Philippines, which now owns 6.
Satellites are built with unique parts that specifically serve distinct functions. However, there are still some parts that are commonly found on most satellites, such as command and data handling, antenna, guidance and stabilization, housing, power, thermal control, and transponders. Let us briefly tackle what these parts are for. First is the housing, which is made from materials that have good stiffness and strength properties that could withstand the harsh environment of space, like aluminum alloys, titanium, or carbon fiber reinforced polymers, also called CFRP. Enclosed by it are the smaller parts that are susceptible in space. This includes command and data handling, thermal control, and transponders. The command and data handling manages and monitors the overall state of the satellite, as well as receiving instructions from Earth for its operation. This is the reason why it is also treated as the heart of the spacecraft. Next is thermal control. This guards the equipment from the harsh changes in temperature, starting from the satellite's launch up until the end of its service life. third is where frequencies received by satellites are getting repeated or converted, the transponders. Now, outside the housing is where antennas are found. This is where the signals created by frequencies are received and transmitted back on Earth. Next is the guidance and stabilization. These contain sensors that ensure that the satellite remains in its orbit so as to minimize crashes with other satellites and to make sure that it faces its correct target. Thrusters and other equipment are also attached to some satellites that would help maneuver it back to its correct orbit in case of disposition. Lastly, satellites are equipped with materials for its power source. This keeps the satellite working until its service life in space is needed. Two common power sources are solar panels to convert sunlight into electrical energy and batteries. On October 4, 1957, the Soviet Union launched its first successful satellite that was roughly the size of a beach ball. Named Sputnik-1, it was recognized as the first artificial satellite to orbit the Earth for about 3 months. With only 3 silver zinc batteries, its service life was short. However, because of its successful release into space, its mission to get the Soviet Union first to space was accomplished. Additionally, the satellite unexpectedly delivered some information about the Earth's atmosphere due to its transmitted signals, even though it was not carrying any particular equipment. After this, NASA was formed by the Americans in response to the Soviet Union's achievement during the Cold War. The established administration was tasked to lead the country's space and aeronautics research, as well as its explorations. From then on, NASA launched various notable missions, including the famous Apollo 11 and America's first successful satellite, the Explorer-1.
Fall of 1957, Americans had no idea that a small metal sphere weighing around 180 pounds was about to turn their world upside down. On October 4, 1957, the Soviet Union announced it had launched the world's first artificial satellite, Sputnik-1. As the satellite sailed around the Earth, the United States could only watch. It was official. The first man-made object was orbiting the Earth, and it had been put there by enemy number 1. Overnight, the balance of power had shifted from the US to the Soviet Union. The US had suffered a propaganda setback from which it would take years to recover. The US had a lot of catching up to do in the realm of space exploration. The Cold War intensified, and the space race was on.
The Philippines may have fewer satellites than the other countries, but they are definitely not new to it. During the 1990s, the country had already launched satellites that benefited its people. First was the privately owned Agila-1 or Mabuhay. It was acquired by Mabuhay Satellite Corporation under PLDT in 1996 from an Indonesian company, but was launched way back March 20, 1987. Next is the Agila-2, which is a Philippine-owned satellite from China.
These two preceding satellites have proved to make Filipinos' life better by improving means of communication and receiving information. Even so, the Philippines still relies on other countries' satellites to get updated with the recurring effects of climate change like typhoons. Soon enough, the country found its own solution. Released on April 27, 2016, PHL MicroSat-1 was the first microsatellite made by Filipinos. It orbits the Earth for 100 kilometers above ground while surveilling about Philippines in about 1,000 of its selected areas. It's akin to a coffee table with dimensions of 55 by 35 by 55 centimeters, and it weighs around 50 kilograms. Despite being small, it actually does a lot of things that truly serve the public.
The satellite was built with 4 cameras that focus on different matters such as cloud formations and vegetation. With its high-precision telescope, or HPT, the microsatellite is able to help in assessing the damages brought by a calamity or disaster to an area and also serve as a surveillance camera for natural and cultural sites like the Mayon volcano in Bicol and rice terraces in Cordillera. It also has a spaceborne multispectral imager, or SMI, with liquid crystal tunable filter, LCTF, which is responsible for observing changing patterns in vegetation as well as the state of ocean and coastal ecosystems. Despite not being a total weather satellite, its third camera, which is a wide field camera, still helps in accurately predicting weather patterns by capturing images of cloud formations. Lastly, this satellite can also aid with forest management, preservation, and gathering geographical data using its medium field camera along with its other optical payloads. Other than these specialized cameras, it also has amateur radio unit and localization of payloads, which also helps the PHL MicroSat-1 in carrying out its mission in space. With its special cameras and equipment, the Philippines' first microsatellite circles the Earth and passes over the country 4 times a day.
Lulunsad na sa Abril ang kauna-unahang satellite sa outer space na gawang Pinoy. Ano nga ba magiging pakinabang natin dito sa Diwata-1? Yan ang inaksyonan ni Bimbo Santos.
Matapos ang dekada-dekadang pangangarap at higit 1 taong pagpaplano, nabuo ang Diwata-1. Ito ang kauna-unahang satellite ng Pilipinas na dinisenyo at binuo ng Pinoy scientists sa tulong ng Japanese experts. May 4 itong kamera at halos ang laki lang ng balikbayan box. Pagdating ng Abril, hindi na pantasya lang ang istorya ng Diwata-1 dahil inaasahang o-orbit na ito sa mundo.
Hindi na mystical ngayon ang satellite. Within reach at talagang ginawa na natin.
Ngayong araw, ito turn over ng DOST ang Diwata-1 sa Japan Aerospace Exploration Agency sa Japan. Mula Tokyo, ihahatid ito sa Amerika para dalhin ng SpaceX sa kalawakan. Kapag nagkaroon na tayo ng sariling CCTV sa ere, maraming sektor daw ang makikinabang. Malaking tipid para sa gobyerno, lalo na kapag may sakuna, dahil hindi na kailangan bumili ng satellite imagery na milyon-milyong piso ang halaga.
Diwata-1 kasi will pass by the country twice a day. And during those times, it will be imaging parts of the country for various purposes. Pwede siya for weather forecasting, pwede for agriculture, security and military purposes, even infrastructure development, disaster mitigation, and so on.
Naglaan ang DOST ng 840 million pesos para sa satellite program. Sakop nito ang Diwata-1, data receiving station sa Subic at ang Diwata-2 na lilipad naman sa susunod na taon. Umaasa ang DOST na ang Diwata-1 ay magsisilbing inspirasyon para sa mga Pinoy sa pag-abot sa mga pangarap na inaakalang kathang isip lang.
With this span, it can already capture up to 3,600 pictures, send messages to Pedro or the Philippines Earth Data Resource and Observation Center, and monitor disaster damages, weather patterns, changes in natural and cultural heritage, and serve as a guardian of the country's forestry, agriculture, mines, and seas, truly befitting of its common name, Diwata-1. This feat was once only a vision for the country, but with the collaboration of the Department of Science and Technology, University of the Philippines, Diliman, and to the Japanese university, namely Hokkaido and Tohoku University, it became a reality.
Sa ibang balita, isinapubliko na ang kauna-unahang larawan ng Pilipinas na matagumpay na nakuhanan ng Diwata-1 microsatellite. Sa pamamagitan ng medium field camera o ng MFC, malinaw na nakunan ng Diwata-1 ang Isabela region. Ang MFC rin ang ginamit upang makuhanan ng larawan ng isang parte sa northern Japan noong Mayo 9. Maliban dito, sa pamamagitan naman ng wide field camera ng naturang satellite, nagawa ring kuhanan ng Diwata-1 ang magandang larawan ng mga ulap sa Japan nang dumaan ito sa naturang bansa noong Mayo 5. Matatandang ang Diwata-1 ay pinakawalan sa himpapawid noong Abril 27. Inaasahang magtatagal ang naturang microsatellite sa orbit humigit kumulang 2 taon kung saan makakatulong ito upang mapaghandaan ang anumang darating na kalamidad sa bansa.
Behind this satellite's creation were 9 remarkable Filipino scientists, and among them was engineer K. Christine Vargal, the sole woman of the group, who manages the day-to-day planning and commands for Diwata-1. Her role reflects not only the brilliance of Filipino scientists, but also the growing presence of women in STEM, showing how inclusivity in science strengthens society's progress. Moreover, the creation of Diwata-1 did more than just capture photos. It became a symbol of hope that Filipinos are not just bystanders in space exploration, but pioneers who can reach it themselves. From relying on others to creating their own, it was more than just metals and lenses. It was a leap forward for the country's society and technology.
I'm John Lur Labrador. I'm the current Chief Science Research Specialist under PhilSA of the Spacecraft Mechanical and Autonomous Systems Development Division. Quite a long title really, but anything that's related to the mechanical side and anything that works on its own, the autonomous aspect of spacecraft, satellites, kami yung division concerned on those matters.
So, engineer, I hear you're behind the Diwata project.
Yes, I was part of the team that was sent to build Diwata-1 as well as Diwata-2. So, Diwata-1 was way back in 2015. We were a team of 4 engineers from the university. May 2 engineers from DOST-ASTI. And may sumunod na 3 engineers who worked on the payload side. So, we were a team of 9.
There are 3 replicas of MicroFieldSat-1 that were created to help the public learn more about the Philippines' first microsatellite, Diwata-1. These replicas are displayed in different locations so that more people can see and appreciate them. One replica is located at the office of PFST in Marikina along JP Rizal National Road. Another is in Eastwood, Quezon City on the 29th floor of the Cyber 1 building at 11 Eastwood Avenue, Bagong Bayan. The third replica is placed at the Taguig National High School, where students and visitors can learn about space technology up close. These replicas are exact models of the real Diwata-1 satellite. They show the actual size, structure, sensors, and components used in the microsatellite. By viewing these replicas, students, teachers, and science enthusiasts can better understand how Diwata-1 was designed, what equipment it carries, and how it operates while orbiting the Earth. Because of this, the microfilsat-1 replicas help promote interest in science, engineering, and space exploration in the Philippines.
Aside from their permanent location, the replicas are also brought to various educational events. For example, one replica was showcased during Robotics Week at Colegio de Muntinlupa, giving students a chance to explore how satellite technology connects to robotics engineering. They are also featured during Philippine Space Week, celebrated every August 8 to 14, where schools and organizations highlight the country's milestone in space science and technology. In 2025, a microfilsat-1 was also exhibited during the DOST Region 6 Regional Science, Technology, and Innovation Week, held in Rojas City. Copies from September 10 to 12, 2025. During this event, the satellite model became a key attraction, allowing participants, students, and educators from Western Visayas to learn about the country's achievements in space technology. The presence of the replica helps spark curiosity, encourage scientific learning, and inspire the next generations of Filipino innovators.
After the successful launch of Diwata-1, the country not only celebrated but also immediately began working on its successor alongside another nanosatellite released from the ISS named Maya-1 and Novasar-1, which the DOST ASTI signed a capacity sharing agreement with the United Kingdom. In July 2018, Diwata-2 was launched, carrying the same but upgraded features of the former microsatellite, this time orbiting 600 kilometers above the Earth. And within the next few years, the Philippines had already launched 5 other satellites. In 2021, Maya 2, 3, and 4 was launched, with Maya 3 and 4 being the first batch of university-built satellites of the Philippines, and after just a year, it was followed by Maya 5 and 6. In proving that Filipinos just keep on outdoing themselves, this year of 2025, the Philippine Space Agency or PhilSA announced that they are already preparing to launch MULA or Multispectral Unit for Land Assessment, which is said to be the country's most advanced Earth observation satellite yet. It was expected to launch in mid-2026. What is something to be even more proud of is that this mission is predominantly conducted by Filipino engineers, unlike the previous satellites that are heavily assisted by foreign professionals. Little by little, this shows how Filipinos are paving their way into the global space community with eagerness to help for the betterment of their country. With the efforts of Filipinos, these satellites became milestones, opening doors of opportunity for future generations of scientists and engineers. They proved that innovation is possible, even in places once thought too small to dream of space. From a single bird's eye view, we now see beyond the storm, the sky, the land. And from it rose a guardian who watches over its people and riches from above. protecting and guiding them with all its might. Diwata-1 not only carries scientific purposes, it carries the Filipinos' pride, culture, and name. By simply orbiting as a microsatellite, it has already marked its place in history and represented how much Filipinos can achieve with resiliency, curious minds, and trust in themselves. If Diwata-1 can rise above the storms, carry the pride and identity of every Filipino into space, then what is stopping us from supporting our nation's innovations, nurturing our curiosity, and taking part in building a future where we all rise together?